Hey, fellow problem solvers, Colfax Math here. I am in IB Math SL, Analysis and Approaches, Topic 5, Calculus. And what we are going to do today in this problem is find a max, a min, and an inflection point. We're going to go over a few different things. Some of the things we're going to do is find the derivative, set it equal to 0. But then now that we know that slope is equal to 0 there, we don't know if it's a max or min. So we could figure out if it's a maximum or a minimum by using a sign diagram. And then the other thing we're going to do is take the second derivative, which will do the same thing as a sign diagram to help us tell whether it's a max or a min. Okay, so you might want to pause the video here and try and do this problem first. Find the maximum, minimum, and point of inflection of this function right here. Unpause the video and watch how I do it. So first thing I'm going to do is I'm going to take my function and find the derivative of it. So if f of x is equal to 2x to the third minus 4x, a cubic function, then the derivative is going to be 6x squared minus 4. So there's my derivative right there. I'm going to take that derivative and set it equal to 0. So now that I have my derivative, I'm going to set it equal to 0, meaning my derivative is my slope. Where is the slope? 0. And then I'm going to solve that equation. 6x squared minus 4 is equal to 0. Add 4 to both sides. 6x squared is equal to 4. Divide both sides by 6. And then x squared is equal to 4, 6. I'm going to take the square root of both sides. And x is going to equal plus or minus the square root of 2/3 or square root of 4, 6. So I'm going to have two solutions here. I enter the square root of 2/3 on my calculator, and I get 0.816. That's going to give me an x value on my graph. I want to find the corresponding y value for that. So when x is 0.816, what is the y value on the graph? I take that 0.816, I plug it in here, 0.816 cubed times 2 minus 4 times 0.816. So my first value of 0.816 gives me a y value of negative 2.18. But remember, when I take square root, I have two solutions. So let's find that second solution in red here. So when x is 0.816, when x is equal to 0.816, my y output is negative 2.18. And then now let's find the negative value. When x is negative 0.816, I'm going to take that, again, plug it into my original function. Negative 0.816 cubed times 2 minus 4 times negative 0.816 is going to give me a negative 4.35 value. So now I have two different points where the slope is equal to 0, and I need to set up a sign diagram to see how the slope is before that point and after that point. Is it approaching it with a positive slope and leaving it with a negative slope, or vice versa? So I'll set up a sign diagram here first. I know that when x is negative 0.816, my slope is 0. I'm going to pick a point on each side that's going to work pretty well, like negative 1 and 0. When x is negative 1, I plug it into my derivative because I'm looking for slope, right? This is my slope equation. Negative 1 goes in there. Negative 1 squared, positive 1 times 6, positive 6 minus 4 is positive 2. So at negative 1, it has a positive slope. I'm going to try 0. Plug 0 in there. This whole thing becomes 0. 0 minus 4 is negative 4, a negative slope. So at negative 0.816, it approaches with a positive slope, hits 0, and then leaves with a negative slope. So I could see that this is actually a max. Okay, let's do the same thing for the other value. So now right here on my sign diagram, I have 0.816. The slope at that point is 0. Pick a value to the left. 0, a value to the right, 1. 0 goes in there. That gives me -4. That's going to be a negative slope. I'm going to take that 1, plug it in there. Squared times 6. 6 minus 4 is +2. Positive slope. And it looks like that. So this looks like a minimum. Now it looks like a maximum. And these are coordinates on my actual graph. We'll go over to Desmos and look at it, or a graphing calculator. From there, now we're going to look at the second derivative. So the second derivative, running out of colors here, the second derivative noted f double prime of x, or d squared y over dx squared, or y double prime, is a second derivative. Second derivative is just the first derivative taking the derivative of. So I just have to take the derivative of the derivative. So f prime of x here is going to be 12x minus 4x is 0. Right, that constant just disappears. So there's my second derivative. The thing you want to put down in your notes is, first, if the first derivative is equal to 0 and the second derivative is greater than 0, meaning if the second derivative is positive, then you will have a minimum point. Or if the second derivative is negative, you will have a maximum point. So here's my point right here, 0.816. I put it into my second derivative. 12 times 0.816 is positive. It is positive, so I know it is a minimum for this green one. Right, so this is a minimum, as we found out with our sign chart. Then now let's take this value right here. Our other coordinate is negative. I take that negative 0.8, multiply by 12. That's going to give me a negative value, right? I don't actually care what the value is. I just want to know positive or negative. But negative 0.8 times 12 will be less than 0. It'll be a negative output, so this will be a max. So two ways to do it. One is a sign diagram. The second is to take the second derivative, plug it in. If it is greater than 0, if it is positive, it'll be a minimum. If it is negative, it'll be a maximum. So here are our two coordinates, 0.816 and negative 0.816, and the corresponding y values. Let's just see what all of this looks like graphically. So I'm over here in Desmos, and I could see that negative 0.816 right there with that corresponding y value is a maximum point. My slope going towards it is positive, 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 0, and then negative, negative, negative. This coordinate right here, over 0.816, up negative 2.2, is my minimum. Here I have that negative slope, negative, negative, until my slope hits 0, and then my slope's positive. And we found that that is a maximum and a minimum two different ways. The first way we did it with the sign diagram, positive slope to 0. No, I'm sorry, negative slope down, 0 positive slope, and that's where we got that minimum. And then on this number here, right, graphically, this point was on the other side. It was positive slope up to that max. That max was 0, and then negative slope going down. Besides having a max and a min, we might have an inflection point. The way we find that point of inflection is we take our second derivative, set it equal to 0, solve for x, and x is equal to 0. Once I have that value for x, I plug it into my original function and see what y is. 0, 0, that whole thing is 0 minus 0. So I have a coordinate 0, 0, where my second derivative is equal to 12x set equal to 0. And then that's a point of inflection. We could see that point right here graphically. And this change is a change of the curvature, right? This is concave down, and this is concave up. So that's our point of inflection. And then from there, we could set up a sign diagram with this point. If we set up the sign diagram on this point, we would see that it has a negative slope before, the point of inflection, and a negative slope after. So a lot of information here. The main ideas, again, for a calculus class was find the maximum and the minimum, figure out concavity up or concavity down, and then find a point of inflection. If you have any questions, post them in the comments. Thank you for watching.